Okay, so guys, try not to tear up here, but this is the very last video that I'm making for you and your curriculum. It's been a blast. I totally miss all of you though, and wish that we were still in the classroom together. But here we go. Example 11 from chapter 24, your last example. Find the mean and the standard deviation of a normally distributed random variable x if we know these two facts. Okay, so we're going to work with each of the facts separately to begin with. Okay, remember keyword normally distributed, so we know that this is true. We're dealing with a normal distribution. All right, let's deal with the first statement first, which is this: probability that x is less than or equal to 20 is 0.1. All right. I think I forgot to write the final part of the question down here. Find the mean and standard deviation. Oh no, it says it right there. Find the mean and standard deviation. Okay, so we don't know either of them. In the previous example, we knew the standard deviation. We had to calculate the mean, or we could do vice versa, the same way as in the previous example. But this one, we need to find both. Okay, so if we have two unknowns, then we need two equations. So that's what we'll be working towards, finding two equations so we can solve for two unknowns. All right, so first information we know is this. 10% of the data is below 20. All right, so let's just draw that here. Put a 20 here, and this is 10%. Okay, all right, we can handle that. So we can say, I'll just rewrite that down here. All right, so we could say, do you know what we need to do? We need to find the z-score that is in that exact same position. So what we'll do is we'll talk about that. Z less than or equal to some little z, 0.1. And we will do inverse normal 0.1 with 0 and 1 because the z distribution, so we'll find that number. Menu, probability distribution, inverse normal, 0.1 for the area and 0 and 1 for the mean and standard deviation because we're looking at the normal distribution. Standard normal distribution. Our z-score for that is negative 1.28155. Okay. All right, so now we will have one equation. We will have z equals x subtract mu over the standard deviation. We can put in what we want to put in, and we'll have negative 1.28155 equals x value we know, that's 20. Subtract this over this. Okay, so let's put that in an easier form to deal with. Negative 1.28155 mu. Sigma, sorry, equals 20 subtract mu. 10 minutes of supper? Okay, thanks. No problem. All right, so this is our first equation. There we have it. Our first, whoops, not that part. This is our first equation. Okay? All right, let's deal with the second part. Probability that x is greater than or equal to 29 is 15%. Okay, so we're looking at a greater than 15%. Okay, so somewhere here, say we're looking at this, and this is 15%, and this value here is 29. Okay, all right, so this is the information we have. Remember, we can only do less thans though, so we need to change this around to a less than. And then this would be 0.85 because it has to be 1 subtract this. So now we're saying this is 85%. From here to here is 85%. Okay? All right, now let's find the z-score that accompanies this. Oh, and I also should write down the z-score that accompanies this. Here, this is x, and the z-score that accompanies it was this, okay? All right, so we want to say probability that z is less than or equal to what little z, what z-score? 0.85%. Calculator, menu, probability, distribution, normal, inverse norm, 0.8501, and we get, for some reason it didn't do it for me, I have to redo it again. 0.8501, must have pressed cancel instead of okay. 1 point, so inverse normal, 0.8501. So z, little z is 1.03643. All right, let's create our second equation. Z equals this, so 1.03643 equals the x value was 29, and we don't know either of these things. All right, there we have our second equation. All right, and I'm going to write, this is an x, and there was z that went with it, as this. Okay, so thinking about the x distribution, so the actual data set we're dealing with, I'm calling the x distribution, there's the values, and overlapping the z distribution right over top of it. Okay, so in the same position, these two numbers would be, in the same position, these two numbers would be. They are related based on this formula. So fill in that formula, two equations, two unknowns. Okay, I'm going to copy them down here and then solve them. Okay, can you guys still see that? I think you can. So, going to subtract these two equations, because if I do that, then the mu will be eliminated. So, two equations, two unknown simultaneous equations. You can choose to use substitution instead if you want, or you can use elimination like I am. Okay, so if I'm subtracting, because that'll be negative mu, subtract negative mu, which would be adding mu, which would be 0. 20 minus that, okay, that minus this. Negative that, with this unknown, therefore, and hopefully I'm doing my arithmetic correct. Usually you guys are here to help me out and fix my little mistakes that I make on the board. 3.88262. 8826. Whoa, what did I say? 3.88269. 269. Okay, so we have this. Now, put this back into one of our equations. And you guys can't see that, can you? There's the answer. Okay, there we go. Put that back into one of the equations. Let's say this one because that's positive, it just seems easier to work with. (29 minus mu). So multiply those two numbers together. Times 1.03643. 4.02. Just keep the top off this marker. Sorry, guys. 4.02414. So this equals 29 minus this. 29 minus that answer, 24.9759. Okay, so 3 significant digits for final answers. So therefore, standard deviation, 3.88. And mean, 25.0. That would round to. Is that the same answers they got? 25.0, 3.88. Yes, it is. Okay, so just creating 2 equations with 2 unknowns using simultaneous equations to solve them. Have fun with it, guys. I've had a lot of fun with you. Can't wait to see you again.